Yeah, so first, this is like the traditional RAG pipeline. We usually start with having like a bunch of documents, maybe in different formats. We start by the first step, or the first main step is the indexing, in which we start first with splitting the data into meaningful chunks, and this splitting have different techniques. Then we take these chunks and we convert them into vector embeddings, and the next step is to store this vector embedding. Now we have the data indexed and stored in the vector database. And the vector database is optimized for semantic search, so we can, after that, when the user have the input query here, we will go and also create the vector embedding of this of this user query, or this input query, which is usually like the user question. And we go to the vector database, retrieve the most similar chunks, and also there is different retrieving techniques that we can use. And then we have the top k chunks, and then we take these chunks and feed them to the LLM to get the response. And why we want, or what is the purpose of using RAG? Sometimes we want to chat, or the LLM to have an access on a certain document that he hasn't seen in training, maybe some private documents or some on-premises documents that the LLM has not been trained on before or fine-tuned before. But the LLM has some context about, maybe it's something in finance, so the LLM knows some finance, but it does not know like the financial report of a certain company, because it's something internal. So we want the LLM to ask, or to be able to ask the LLM questions, and he give us the answer, but he should use the documents. That's why you want to do this. So first we take the documents, we do the whole process, and then we get response. There is some problems in this RAG, usually the accuracy of retrieving the answers, um, and also it's like we can see there is multiple steps in it. We can go to the RAG, and also there is still some, although the LLM or this RAG pipeline usually is very good in avoiding hallucination, but we can get some hallucination in it. So we can, like, one of the techniques that was uh, used to avoid or to overcome the uh, RAG disadvantage, or the RAG cons, is the agentic RAG. From one side, it's easier, as we can see, or as we will see, and also we can add more and more tools to it, so it can become like very powerful. So in this session, we will build this agentic RAG pipeline. So we start also with the input query, but what is different here is that we can have a router agent where it will routing, or it will do some routing based on the input query. So if the input query can be answered from our documents here, it will go to the RAG tool, which will be just a tool. So all of this will be just in this small tool, and this tool have access to our document. So first we have a router agent, which is also powered by LLM, which can see if our question can be answered based on the documents. If yes, it will go retrieve the most similar chunks and so on, as we have explained before. If not, we will give it an access to a web search tool, where it can go to the web and do some search to try to find the most suitable answer to our question. After that, if it go to the routing, or if the routing agent routed us to the RAG tool, it will go to the retrieval agent, which is main task is to retrieve the answer from the documents. After that, we have a grader agent, and the purpose of this agent is to make sure that the answer, whether it's from the RAG tool or the web search tool, it's relevant to our input question. Here one. So it's also an LLM which compares the question that we have with the answer that was retrieved either from the RAG tool or from the web search tool, and see if it's relevant to the question or not, if it answers the question or not. And after that, we have like hallucination grader agent, which is also an agent powered by LLM, and also it reviews the answer, make sure that it's not have any made up facts. It's just to avoid hallucination. And finally, you have the last agent, which is the answer generator agent, which generates the answer. It can add some parts using the LLM. So it's similar to this last step, the generation step, and then we pass the response to it. And as we mentioned, we can have here two LLMs. We can have the main LLM which orchestrate all the agentic workflow, and we can have another LLM here for the RAG tool, which is will retrieve the answer and generate the answer for our input query. And in both we will use DeepSeek, but we will use this one will be from Grok, and this one the one that orchestrate all our workflow will be from OpenRouter. You can use also Olama. I will show you the code with it, but I can't run it on my machine because it will take much time, and also sometimes it fails because of the runtime error for CrewAI. We will use CrewAI, which is an workflow also to build agents. So let's start. Here is the code. I will just run it first to show you what is going on, and then we will start. We will open like an empty project, and we'll start building it step by step to see how it's going. So first, I will just activate the environment here we have, and I will run the main file on the app. It will take around 10 minutes. The reason for this I will also explain why usually it's not that slow, but because we here are using, as I mentioned, the main LLM we are using is from OpenRouter, and this is one is free, but it takes too much time. That's why it will take a little bit more time than expected. This is one, if you want to use Olama, you need to first install Olama, and I will show you how to do it, but I can't, I have tried to do it on my machine, it takes too much time, and also sometimes it fails, so that's why I will not try it here, but I will give you the code also if you want to do it with DeepSeek locally or with Olama. Yeah, let me also till the running finish go with show you the code. So here we have like three main files for our agentic workflow. We have the tools, the ones that I showed you here, these tools, and we have the agents. We will define each one of these agents, and finally we have task, which defines the agentic workflow. What is the task of each agent? So we just made three files for each of them. The tools, the agents, and the task. Then we have like an app, which like call all of them and wrap everything with each other. So we can see here it start to install the model and because also we are using embedder from Hugging Face, so it need to install it. So the first tool here is the RAG tool, which is we called here like PDF tool. We use the PDF search tool from CrewAI, this one. So here we have CrewAI underscore tools, and we have the PDF search tool, and it takes two main things. First, it takes a PDF path, the path of our files that we want to search through it, and it takes the LLM, and it takes the embedder. So here, as you can see, the LLM is DeepSeek, and we use Grok. Grok is like a LLM provider. You can use their API, and the one thing that is very interesting about Grok that they have very optimized inference time. So usually it's very fast compared to other provider. And also I will show you how to use it when we start building. And the embedder is just this one, like as we mentioned here, that we need to take the documents and convert them into embeddings. So here we are using just an embedder from Hugging Face. You can some models you can use their embedding, but CrewAI is not supporting Grok as an embedding provider. They just have certain provider like Hugging Face and some others. So this is the first tool. The other tool we have also is the web search tool, as we mentioned here. See in the agentic workflow, we said we have two tools. The first one is the RAG tool or the PDF search tool, and the other one is the web search tool, which depending on the decision from the router agent, we will either go to the RAG tool or the web search tool. So the web search tool we are using also an API called Tivoli Search. It can give us access to the web, and we can retrieve here the top three answers from this tool. Also, we can see, I will show you how we can get the API key for them and so on. Second file we have here is which is like the core of our agentic workflow, which is the agents. So here we will define first the LLM. As I mentioned, we also will use Open Router and we will use DeepSeek from it. And we have first the router agent. Yeah, here it's in action. So yeah, first agent is router, and as we see here, its task is to analyze the question and see determine the search method, whether it's vector database or web search. And we can see like the final answer that it's vector database because the question we asked here is the question. What is a self-attention mechanism in transformer, for example, and we have the data, the files that we put in our dataset is attention is all you need paper. So it of course can find it in the vector database. So you can see that the decision of the router agent is to go to the vector database, and then we have it will go to the second agent, which is the retriever agent, which will retrieve the answer for us, and it will go and we can see. So here is the first agent we have, which is the router agent, and it decide whether it should go to the vector database or the web search database. So for each agent we define multiple things. First we define the rule, so we can say that this one is its rule is a router, and then we define the goal for it. What is the main goal? So here our goal is to route the user question to either vector database or web search. Here you can define maybe multiple sources for finding the answers. So you can have maybe vector database, as we have. You can have maybe graph database if you have like relation between different clients. You can have the web search database as a web search tool and so on. So you can find multiple tools based on your applications that you are building. Then you define the backstory, which is like the story for this agent. You can deal like with the agent as it's a person or an expert in a thing, and then you start telling the backstory. You are an expert in determining whether a question can be answered using the information stored in our vector database or require a web search. You understand that the vector database contain comprehensive knowledge base. You make routing decision based on the semantic meaning of the question rather than just keyword matching. And this actually it came by like uh, multiple rounds. I tried different prompts, and usually what was happening that it was just matching the keyword. So that's why I have to add this last line to make sure that it search for the semantic meaning, not only the like keyword matching. And also here you can allow delegation if you want to if you want to allow delegation to another agent. If it fails, you can say if you cannot decide, you can delegate this task to another agent, but here we don't need to do this. So this is like the first agent we have. And here, and also of course you pass the LLM, which is like the brain of this agent. The second agent we have is the retriever agent, which uses the information retrieved from the vector database to answer the question. So this is the goal, this is the rule of this agent. And the backstory also, you have to tell it like a backstory to understand its task. So we can see here you are an assistant for question answering task. Use the information present in the retrieved context to answer the question. You have to provide a clear and concise answer, and so on. Then we have the grader agent, which grades the answer. So the rule is answer grader, filter out wrong retrievals, because sometimes the like the retriever agent can retrieve multiple chunks from the vector database. Maybe some of them might be irrelevant, might be wrong. So we need to make sure that, or to add an agent, as we mentioned, that take only or filter out only the filter out the wrong answer and take only the right one. So, and here we tell it the backstory. So we are a grader agent that grading the retrieved document and so on. And here we have like hallucination grader, which also hallucination grader. The goal is to filter out hallucination, and then we tell the backstory. And we have the final agent, which is the which like filter out any relevant information and generate the final answer. Let's see here the main actions, and we will start building it step by step in another file. So yeah, here we first have the router agent as we mentioned, and here is the task of this agent, and we can see he just first like explain himself, and then he tell you the final answer. He will go to the vector database. Then we have the retriever agent, and he tell you his task, and also if he encountered any error, he will tell you, like for here he encountered an error for the embedding dimension, so he will repeat himself again, and he will retrieve the answer. So if he fails for maybe one time, he will try again till it works. And here he retrieved like the part of the part of the answer that is relevant from the PDF we have. Okay. So here he was not able to retrieve from the PDF, for example, so he will go to the web search tool and will try to get the answer from it. And if he made any error, so he keep trying till it succeed. Yeah. Okay. Yeah, so it keep fails for a certain reason. I'm not sure why it was not failing with me before, but it's okay. Um, so finally, I think it used the it used the PDF to get this chunks, and then it will create an answer for it. It will go through the answer grader to make sure that the retrieved answer is relevant to the question, and then so here yes, it's relevant. The hallucination grader, there is no hallucination, because if yes, we have found this before, as we will see in the tasks. If yes, this means that there is no hallucination, so it can go to the last agent, and this one will create this final answer. What is the self attention in transformers? Here is the time taken. As we mentioned, it takes a little bit more time because we are using the open router DeepSeek model. If you, for example, I have tried with another provider, and it takes maybe 15 to 30 seconds only. But this is because we are just using the free version from open router. That's why it takes too much time. So let's go to another file. So here talks. Let's create another. Let's create a new folder. Maybe Agentic Rank Life. And we can start building it like block by block. You'll just open. Okay, we can start now. So this is like just empty project. Yes, first step we will use is we will create like a Python environment. So we can have a separate environment for our project. Let's open new terminal, and just work on it. So now this command will just create a new Python environment for us. We can see here it's creating this environment. So we have like a separate environment for our project, and we can start installing the packages we need. If you want to, you can follow me step by step here. This will be really good. Yeah, this takes around 1 minute or something. Let's wait. Okay, this is like the first step. After that, we will activate this environment. Okay. Yeah, then we start with the first part, which is the tools. As we mentioned, we have here um, two main tools. But let's first define some of the package. So here we will find new file tools.py. Okay, and we will need to install CrewAI. And also we need to put like conf file to put inside it the environment variable we will use. As we mentioned, we have multiple environment variable. One for the first one is for the first tool we will use the Tivoli search. We will also import OS, and we will import from .env. We'll import load in .env. These two. Okay. So here we have first the Tivoli search, and we will have the open router and group API keys. And this also downloading the CrewAI package will take some time, so we can do some work till it finish. We need also to install the .env package. Yeah, till finish, you can go first to group. And this one, if you want to get the API key, you can go to the dev console. Yeah, and you can go here to API keys, for example, and create a new API key and use it. And also we mentioned that we will use open router, so you can go to open. And let me sign in here in another screen. And yeah, same here. Also, you go to the API keys. You can, I think, go to models. Yeah, here you can select the model. So if you search for DeepSeek,
Hola, buenas tardes. Soy Marco Luis. Trabajo
yeah,
en
you will
Intel.
find different versions for it, depending on the distilled version and distilled model you have. And here you can see some of them are free. We are using actually this one. And I think to get the keys, you go here and create a new API key. And the final one that we are using is revenue dash API key. Let's see. Yeah, same. Let me sign in. Yeah, same. Also, you can add uh, here an API key and create your API keys, and then you go here, put them into your end variable um, in this file, and then you call it in the conf file, and then we will use it in different parts of our project, as we have seen. And then we have, as we mentioned here, two tools. We have the PDF tool, this one. So let me copy it here. As you can see, as you mentioned, it calls the PDF search tool from CrewAI tools, and also we will have the web search tool. We define it, and we use like a tool dictator to let Python know, or let the agent know that this is a tool, and it will use activity search for the web search. Here it is still installing the Crew AI because it has a lot of dependencies, so it will take a little bit more time. So now we have the two tools that we are using. Second part is the agent, so we will create the agents file. So also we first install some of the packages we will need. We need to import the agent from CrewAI, the LM from CrewAI. Also, we will need from the conf to call the OpenAI router API key. We just defined here from our environment variable. And then we will start to define the LM as we have seen before. So here the LM, we passed the model pass from OpenRouter, and then we pass the OpenRouter API key here that we have just defined. Yeah, then you start like defining agent by agent. First one is the router agent. Second one is retriever agent. And as you mentioned, we define for each agent like the role, the goal, and the backstory. We have here 5 agents. We define one by one. And of course, like especially for the backstory, this is like prompt engineering work. You have to maybe try different prompts and tune it a little bit till you find the best one. The hallucination. And here is the final agent we have. Okay, so now we have defined the 5 agents. The last part is to define the tasks. So let's create the tasks UI. And we will first import from CrewAI task. And then we define also 5 tasks for each agent task. So first the router agent. And in the agent we define like first the description, the expected output, and its agent or its multiple agents that is involved in this task. So for example, in the router task, we have first description is to analyze the given question, and we pass the input question to it, and determine the search method. So use vector database. For example, if the question contain a keyword or similar keyword, or is the topic is likely to be covered in the vector database, and then use the web search if the topic require like current or real time information, if the question is about general topics that are not covered in our vector database, and make decision based on semantic understanding rather than keyword matching. And also with this one I have to add after multiple tries till I this like as we mentioned, it's just like prompt tuning. And then here we give it like what is expected output. So the expected output here is whether it's vector store or web search. And vector store is if the question can be answered from the RAG knowledge base or the vector database. And web search if the question requires external information and no additional explanation or any other thing should be included. And then we give it the agent that it should use. Yeah, the other task we have is the retriever. Also, we can give it like the context, the tool that it can use, for example. So here also we could pass the rec tool if we need. Um, so here we will give it also the retriever agent, the router agent, the rec tool, and the web search tool, all the tools that we have defined, and also the router task that we just defined above, and the retriever agent because it will use it here. And then we define the description for this task, which based on the response extract the answer or the information for this question. And the expected should be um, if the response is web search, then use web search tool to retrieve the information. If the response is vector store, then use the rec tool to retrieve the information from the vector search. And the agent that uh, it's using this task is the retriever agent. Uh, the context of this task is a router task because it depends on this task depend on this task. And the tool that it will be using the rec tool and the web search tool. Then we have the grader task agent define also. So here also it takes the grader agent and the retriever task. And here based on the response from the retriever task for the question, evaluate whether the retrieved content is relevant or not to the question. And the expected output should be yes or no. So yes if the response from the retriever is in alignment with the question asked, and no if the response from the retriever task is not aligned with the asked question. And don't provide any explanation, maybe yes or no only. And here we have the agent that is that will use this task is a grader agent, and the retriever task is the context of it. And so on. We have two more. We have the hallucination. So here based on the response from the grader, evaluate whether the answer is grounded, supported by a set of facts or not. And the answer should be yes or no. Yes if the answer is useful and contain facts about the question asked, and no if it not useful and contain or like have some hallucination, to make sure that the answer is free of hallucination, which is one of the problems of LLMs. And the final one is to create answer task. So this is the final task we have. So first, based on the response from the hallucination, evaluate whether the question is useful to resolve the question. If yes, return like the clear and or clear answer. If no, then perform a web search and return a response. So to make sure that if the retriever failed to, or the retrieved answer from the documents um, have some hallucination or it's not related, it will go to the web search and try to find something useful to it and repeat it again, repeat the whole step again. And then here is the expected output. So return a clear response if the response from hallucination task is yes, because you can see here in the hallucination we told him to return yes if there is no hallucination in the answer, and perform a web search using web search tool, and return. So we might add here the web search tool. I think this will be web search tool, and then we can pass it here the web search tool here. Yeah. Yes, this will be better. Make sure that final answer is clear and contain only the answer to the question, because sometimes it provide explanation how it found these answers, and this will not be useful to answer the final question, and the final answer should be clear and concise to response to the input question. Also, I had to add this line because sometimes the final answer was not very clear, so I had also to do some iterations till I found the best prompt that it's working. And that's all for the tasks. Yeah, it's still installing the libraries. Takes around maybe 10 minutes. I think it's finished. And we will need to install, sorry, we need also to install Crew AI. Yeah, the final thing we need here is also will need to add like a file and or a folder and call it data, and add the PDF, the paper we will use for the RAG application here. Can paste it here. This is the attention one is all you need paper. And yeah, the final file we will use is the main app file itself. So let's also add it. This will just like grab everything and call the functions. So here we will just we will call from the tools we have defined, from the agents, the 5 agents we have defined, from tasks, the 5 tasks we have defined. Yeah, and then we will define like let me go here. We'll define main function. First, we will pass the PDF pass we have. You can also pass it a link here, and you can use maybe this function, for example, to download the PDF. But so we can add here maybe utilities py. This function we can use it to install PDF if you give it like URL of it and the file name to save it. So if you don't have it in your database, you can just install it. But we already have it, so no need to do this. Are in the app, so we'll just pass the PDF file. Then we will define the first tool, which is the RAG tool, and we will create the PDF tool and pass it the PDF file so to create the vector store based on this PDF. Then we will define the agent or create the agents. So here we mentioned we have 5 agents, and then we just create the tasks we have. We have 5 tasks, and every task takes some. Yeah, I think we made some edit here to this one. It takes also the web search tool. Yeah, if I remember. Yeah. So here, yeah, it takes now the web search tool. And just finally, we'll just use grab everything in Crew and create this agent. So here we give it the agents, the 5 agents, the tasks for each agent, and we will keep the verbose equal true just to see what's happening. And we will give it, or we define the start time to see what to see the total time it takes to give us the answer, and the user question here, what is the self attention mechanism in transformer. And we'll just kick off the RAG crew, uh, pass the input query, and calculate the end time and print it and print the final result, and just this to make the codes run when we run it as a script. Yeah, and that's all. We will just install the rest of the package, and we will run the whole. Just you need to run this file, the main file, and now we have it, the agentic RAG. Of course, there is a lot can be done here. You can add more tools, you can add more agents. A lot of work can be done also in the prompt. to improve it and to improve the workflow. But this can be like as a first step to build your agentic workflow. You can also try with different models. You can use Ulama as you mentioned. You can use Ulama in two places. You can use it here. So instead of provider, you can make the provider Ulama, and you can use DeepSeek. And it's very easy. You need to just install Ulama, and then you can maybe from your Windows PowerShell or you from Ulama shell itself, you can just start Ulama. So, and you can install the model. I think it's Ulama run, and we can give it the model. It's DeepSeek R1, and then the size of it is 1.5 B, and it will prot it. And after finishing, you can start using into your workflow. Just you change the provider here and here, and put the model path. And the same here also in the agents. I didn't copy it here. Let me copy it. So instead of using open router, you can pause the model, which is this one, and the base URL, the local host where you are hosting the Ulama service. And also this will be enough to use Ulama and use the LM locally, the DeepSeek locally using Ulama. Yeah, and that's all. We will wait a little bit till it finish, and we will run it again and see how it's working. Yeah, and if you have any questions, we can run. Yeah, sorry. Okay, no worries. I will just send all the whole code to you after we finish. I will upload it on GitHub, and you can find it there, so you can try it. So no worries. Just want to use that to know how everything is done and how you can get the keys and all of the other stuff. But for the code itself, you will find it after we finish the session. How does the router agent know if the answer is in the document? Because the document access is located downstream. Because it have access to the or yeah, we pass the in task here. We pass the rack tool where it's have the vector database stored already and created. This is the first thing is done. So it will see if it just compares the semantic meaning between the question and the answer and see if there is a relevant answer or not, and if yes, it will pass you there. If not, it will let you into the web search. Yeah, do you have any more questions? Do you
Actually, I have a
enjoying it?
question.
Yeah, sure.
Yeah, what is the rack tool does exactly? I'm not sure.
Yeah, so the rec tool is just let me show the thing we are here. Yeah, so the rec tool actually like it's all of this in just one function. So it loads the PDF, it chunks it, it stores it in vector database, and then so it mainly does this part, the first part, the data indexing, and the retrieval agent does this second part. Basically, yeah, we can consider it as this. And also the routing agent uses maybe do this part. It retrieve the or it searches the vector database and see if there is um, any semantic um, intersection or any semantic chunks that can be retrieved and answer this question. So we have two agents that do this retrieving part, and maybe like basically the React tool do the indexing part more or less.
Okay, got it. Thank you.
So I think another question here. Yeah, I will send you a follow-up email with the recording of this session and with the GitHub link, but it mainly will be here. It's not yet updated, but it's not yet uploaded. I will upload it after the session. it will be here, I believe. So I will upload the code in this repo. I've sent the link in the chat. It's not yet uploaded, but I will load it. I will upload it after the session. Inshallah. Yeah, it takes a little bit more time, but yeah, I think after we finish, we'll just have the same thing that I showed at the beginning of the session. So if you want to leave, it's okay. If you want to stay, if someone want to make RAG agent as service, what resource should I learn to host such service for production? Um, yeah,
Thank you, Yusuf, for such a impressive presentation for the RAG tools.
yeah,
Could you but answer my question for if I wanted to learn more about hosting a service I made with using CrewAI or RAG? Is there some materials, some guides how to host like a service, a RAG service
yeah. You
for
mean
production?
deploy it, right? Yeah,
Yeah,
you can
yeah.
use like you can use AWS. You can yeah. So like currently, I'm at my job. We are building also RAG tool, and we are hosting it
Mm-hmm,
as on AWS.
mm-hmm.
Um, yeah, just like you have to do the Docker file and so on, and just deploy it.
So
Yeah,
using a simple EC2 AWS service would be enough, or should I look for something as
yeah,
uh,
I think
a
it will be enough.
GPU?
Yeah, you
Oh,
can add GPU to the EC2, I believe. So
oh, okay.
yeah, you can do
Um,
this. Yeah,
okay. And do you recommend hosting on the service itself or just using APIs from OpenAI or DeepSeek or something like that?
it depends a lot. So if you want to build something fast and reliable, you can just use API because it's very
Mm-hmm.
fast and it will not
Yeah.
break. If you have like some privacy concern and for the cost, I think it will be also cost effective to use your own model, but it will take some more time to host everything, and also I think you will need more work on the maintaining part.
Uh-huh.
Um, yeah, so it depends on the time frame and on the requirements,
Okay.
but both of them are possible.
And is there something I should consider regarding queuing and the for requests? Like, is there some problem if multiple users send a queue, send a request at the same time? Is there a way to handle such tasks
Yeah, you can.
for
I
the?
think yeah, you can use like a load balancer, and so it just like a basic or not a basic. It's more like backend stuff, but you can use like a
Okay,
load balancer and so on to balance the
just
loads
basic
between.
device things.
Yeah, exactly. Yeah, yeah,
Okay, okay,
yeah.
that's
If
great.
you want like a good resource, I'm currently reading a book. It's on this topic exactly. It's called LLM in Production.
Wait,
Uh,
just let me look.
I
What
can
is it
send
called?
LLM in Production.
LLM in production.
Yeah, it's more about how to. It's
Oh,
just about this
is it
stuff.
on Medium,
No, it's a
medium.com?
book. I will send you the link here. It's from Manning.
Oh, I appreciate that. Thank you.
Yeah, here you go.
Mhm. Got it.
Yeah,
Perfect. Thank
like
you.
the first four chapter, like it starts the actual work from chapter six. The first six chapter is more about like introduction to LLMs and this stuff. So you can
Hmm.
maybe skip the first five chapters or something if you already
Okay.
have like a good background about LLMs,
Yeah,
and you can start from chapter six. This will be good.
from chapter 6.
Yeah.
Okay, perfect. Thank you very much. So, are you waiting for downloads now?
Yeah, I think
What's the
it's
next?
just finished.
Uh-huh.
Yeah, we can continue. I think we have to download one more, but it will take no time. This one, the .env, just to load the env variables, and I think we can after that run our code. Yeah, everything is installed. Yeah,
Hi, Youssef. This is me, Abir. Can I ask you a quick question?
Yeah, sure.
Yeah, so I'm basically kind of you can say new to the LLM thing. I have the previous experience, but compared to your knowledge or the people working, I'm kind of a beginner, you can say. If I want to improve my skills and get more knowledge on the LLMs field, do you have any book resources? Because this kind of a very new, right? So do you have any big book resources that you suggest us to can start with, like in a sequence, one or two or maybe three names that you think will be useful and time efficient to get into this?
Yeah, I would recommend not to go to books directly.
Okay.
What I recommend is to start first with generative AI with LLMs course from
Okay.
deeplearning.ai. This
Yeah.
will give you like an, I can send you the link here. It will give you like an introduction to LLMs and like how, what is fine tuning, how it works. Also, like a quick introduction to LLMs, how they work, and fine tuning, how they work. And also the last chapter or the last week of this course, just 3 weeks, it can be finished maybe in 2 or 3 days. The last one will be on human from feedback, reinforcement learning from human feedback. So just it will give you quick introduction. Yeah, we need to install another package, the group big install. Yeah, I will send the link here. And after that, what I would recommend is to go to deeplearning.ai. They have a lot of short courses. You can start with
Mm,
the prompt engineering course. They have
mm,
two, I think. And then they have also maybe one or two on fine tuning, LLM fine tuning. Just the good thing about these courses, just like short courses, maybe 1 hour, but they have code, video and code, both of them at the same time. So you can try a little bit and get your hands dirty. And
uh,
after finishing this, I think you can start maybe building something on your own. So you can start with like have try to get an idea and start first with some prompt engineering, and then maybe try some fine tuning, and this will be good. And for the books, what I recommend is also 3 books: Build LM from Scratch and Hands-on LMs by J. Lamar. And first one is by Sebastian Rakasha, and the last one is LM Handbook. It's by Maximum. I can't remember his name. But these three
okay.
books are they are taking different aspects of LLMs. First one is just more about just explain every building block of the LLM and how they are trained and so on. Second one is more hands-on on LLM training, LLM fine-tuning, and so on. The last one is more about LLM into production. What are the different tools to deploy LLM and use it in production? So it's like the different aspects for LLMs. So I think this would be really, really enough and really good.
Okay. Could you please repeat the second book that you mentioned?
Yeah, the second book is Hands-on LLMs, Hands-on Large Language Model. Let me put all the resources here. We will
That
just,
would be appreciated. Thank you.
yeah, so Python, let me run the code again. Python. And I will add all the resources. I think I mentioned a lot of them. So first one is generative AI with LM course. So here it is. Yes, someone was asking, is this a book? Yeah, this one is a book. Then I mentioned deeplearning.ai short courses, so I'll just put the link for the short courses here. Yeah, someone uploaded. Yeah, please remove it. I don't think this is a legal version of it. So because yeah, I don't think it's a legal version. So yeah, thank you. Yeah, so this is short courses, and for the books we have yeah, this is the one. Yeah. We have first build. Let me put the links. Build LM from scratch. And second one is hands-on LM. Yeah, just try to take the links because I think it will be deleted after
Yeah.
we close the call. So make sure you take the links. Yeah, the last one is LM handbook. Um, yeah, LM engineering handbook. Yeah, this one. Yeah, this is the resources I mentioned. Let's go back to the code. Yeah, we need to install Hugging Face also. Also, if anyone has any question, feel free to open his mic and to discuss your questions. Yeah, I think this is all the libraries we will need. Do you have any more questions? Just feel free to open your mics. Yeah, it takes a little bit more time than expected. I think maybe because I'm opening Zoom also, so maybe this is the reason. But yeah, anyway.
Hi, Yusuf. I have a small doubt.
Yeah, sure.
Look, yes, actually, these functions are executed on the client side, right? So, can you please put some light with the real-time example on the extensions, how they're executed on the agent side?
Yeah, can you repeat the question? I didn't get it.
So, these functions, what you have mentioned, are executed on the client side, right?
What do you mean by client side?
So, basically, we will be having two executions, right? One by the functions and the other by the extensions.
Okay.
So, can you please give few examples which are executed on the agent side, extensions?
I'm not sure, to be honest.
Okay.
Maybe he wants to see the code working.
Yeah, okay.
I think that's what he meant. I'm not sure actually.
Yeah, I'm not sure also.
So,
But we will see the code working, but just like after installing, we have seen it
But
already.
basically the code just works on the back end because it's
yeah,
Python and yeah. And this
okay,
is just an example, so we're just using command line. And
okay,
for an example from the front end, you just need to create a front end and some API calls to the back end. So this is just a simple example to the back end, and this is how we would work in a simple situation.
okay.
Yeah.
Thank you.
Yeah, thank you. Yeah, it takes too much time. I think it was not a good idea to install the package live. I should have installed it before, but yeah.
Yeah, probably.
Yeah, I just want to make sure, just to show everything in live. So yeah, but I think we already have seen the application working. So if someone want to leave, it's okay. So we'll just run it again. So
Oh, it's okay. I'm enjoying this.
thanks.
So, Yusuf, I have another question actually. So here you have mentioned the functions, right, without making any live API call or else something like that. So,
No, there is some API codes like this LLMs is being used through an API. We are using
yeah,
three APIs. We are using the open router, the group, and the TV research. So these are three APIs we are using.
yeah, I agree to that. You are just pulling the LLM model through the API call, but you are not performing any function, like, for example, getting the data or else calculating some value using the API, right?
Yeah,
Using the other external tool.
yeah, exactly. Yeah.
So, can you please put some light on these stuff actually? So, how it works in the, so for example, if I need any few parameters from the other website, so what they are mentioning in that website, so how can we pull it and in the real time, how it works actually?
Yeah, I didn't get the question. Sorry. Yeah, so you
Yeah.
mean if you are using other APIs, right? Or you mean
No,
this
no,
API?
no. For example, if you have a website, okay,
Yeah.
so in that website, there are few APIs and the parameters as listed. Okay, so I just want to retrieve these. So my agent work is to go to that API, I mean to that website, and see the parameters and pull that parameters. For example, if there are any CRUD operations they have mentioned, just like in that website, or else some keys.
You mean like
Are you
scraping information from
Yeah. Yep.
Oh,
right? Did I understand it
Yes, yes,
right?
yes, yes, yes.
Yeah, so yeah, there is also some like you'll define a tool here also.
Okay. Okay.
And there is currently some LLM scrappers tool that you can provide a link and prompt and will this is just one way you can use it. And
Okay.
it will scrap information from this API, or you can even have like just normal scrapper, maybe using Petrol Soup or Selenium or whatever, and just define it
Okay.
as a tool, and you can post it the URL for this website, and you can retrieve the information. So you can do a lot of tools here. There is no like limitation for it. Yeah, we can see here it start working. So here it's first as we see it's inserting the patches in the Chroma DB, because someone was asking that
Hmm.
the storing of the or how the router agent will have access to the document. So first it installs patches in the Chroma DB, and then the router start work here. And as we can see in action, the router agent, uh, yeah, and it says the task is to analyze a given question and see if it determine whether it can be answered with the vector search or the web search, and the final answer is vector search, because this question is can be found in the data. After this iteration, we will try another question that it's not answered in, or it's not available in the document, and you can see that we'll go to the web search and we can try this. And then we have the second agent will go into action. The retriever agent, it encountered the same error. This error was missing one requirement. Okay, there is this web search tool required on positional argument. Okay, let me see this one. This web search tool should have the query. Need to be in this task, maybe. Mm. Yeah, it's returning back to the retriever. Okay. Yeah, so here is the retrieved document from the PDF.
Hmm.
It's returning part of the paper. Yeah, I just want also to see why the search is not getting that. I think it should be in the app. Yes, I'm saying here that you should pass the question to the web search. Why it's not passing it? Yeah, maybe I have to change this prompt a little bit.
Hmm.
Yeah, maybe you should pause the generation. Should pause the input query. Maybe this will not cause the error again. Let's try again after we finish. But yeah, it managed to go to search to search the PDF, find the retrieve the content from the PDF, and yeah, it
Okay.
should continue. It takes a little bit more time, as we mentioned, because the LLM here we are using from Open Router, which is a little
Hmm.
bit too slow. But it's okay because it's free for so for
Hmm.
educational purpose it's okay. But But of course, for real projects, maybe you need to use the paid one.
It is still giving the same issue.
No, it's just taking some time in retrieving and extracting the information from the document.
Yeah.
Yeah, because like the LLM here is too slow. The API we are using, but it's okay. It's working.
Oh, that's perfect. So basically, the job of the router is just connecting agents, and the agents uses tasks.
The rule of what?
So in the RAG,
Yeah.
there is the router, tools, tasks, and agents, right?
Yeah, there is main three components: the tools, the agent, and the tasks. The task
Mm-hmm.
or the agent has is defined. Its task is defined by the task, and the tool
Mm-hmm.
is like an external tool that helps the agents to do the work. So yeah,
Okay, so I give an agent task and a tool to
yeah,
achieve this goal or task.
yeah, exactly. Yeah,
Okay, and
and they are
what is
just
the
keep
router
both the
exactly?
components with each other.
Okay, and what is the main goal of the router? I've seen you using like something called LLM router or something like the router.
Yeah, the router this one, right?
Oh yeah, router agent.
Yeah, the router agent is just to because we have multiple tools.
Mm-hmm.
So it just router the or it choose like the right tool for this task.
Okay,
Yeah,
perfect. So it works all independently.
yeah, yeah, yeah. So here we can see it's start after retrieving the answer.
Uh-huh.
So now it's retrieve the answer and give us an answer. Then it go to the answer grader, and based on the answer, we can see this is the task to evaluate the answer, and we can see the final answer is yes, means the answer is relevant. Then it go to the hallucination grader, but it takes maybe more time than expected. But it's okay. Yeah, just for educational purpose.
Yeah.
As I mentioned, I've tried before with OpenAI. It was very fast. It takes like around 15 seconds the whole process. It depends like on the rate limit and the rate of this API. So, but of course, because OpenAI is paid one, it's very fast. I tried also with Olama locally, but because my machine is not so good, so it takes also too much time. So it depends
Yeah,
on the resources that you are using. So
exactly. Yeah. I've tried once on my laptop. It took me like 10 minutes for one
yeah,
response.
yeah. It's okay for the
It's-
educational purpose if you want to try something on your own, but
Yeah, it
for
is.
real application, that's why you need to use some APIs. Actually, Grook is really fast also.
Group.
Yeah,
Okay,
yeah.
let me check.
Yeah, we are using it here. Actually, they are using I think LTPUs, not GPUs, and it's very optimized for inference. So it's really fast. I also tried with another project, and we have like very critical response time, so it have to be very fast. And Grook was the best one available on the market. It was better than OpenAI. It was better than OpenRouter. It was really good. Yeah, now we can see it the whole process I have done, and here is the final answer. The time is around 10 minutes. It's very slow, but it's okay for the education purpose. The last thing we will do, we will just try another question. Maybe just ask it something on about real time. So maybe what is the weather in New York City? Something. Let me clear this first and run it again. So now it should go to the web search tool because this question cannot be answered from the vector database.
Yeah.
Yeah, so it should go and depend on or use the web search tool to get the answer from the web and like goes through the whole other process. We will just maybe try or see the first part and then we can conclude it because it will take another 10 minutes. So yeah.
Yeah,
we
don't have the
can
luxury of
yeah
time.
yeah so we can just like see if the router will routing it to the web search tool, and
Hopefully.
then we will conclude like the session here. I hope it was useful. I
Excuse
think
me, Youssef.
there is two questions. Sorry. Could you tell us the recommended courses? Yeah, what is a vector database, and could you tell us?
Yeah,
Oh, okay, so
I sent that.
okay. So vector database is it's a database, but it's optimized to store vectors. What is vectors? Vector is so here we have the input text. This text is first converted into tokens, which is like the building units of the word. There is different token or tokenization techniques uh, depending on the LLM you are using. And after that, these tokens is converted into embeddings, or it's presented into with embedding vectors, depending also on the model you are using. You'll have like no, or we have like the dimension of record, dimension of vectors, and these vectors usually like for example GPT-3, the embedding vector is for each token it's 12,000 dimension, so it's very large. So if it's stored in a traditional database like SQL or not SQL of course, but not NoSQL database, it will be very difficult to do a lot of search, especially semantic search, and try to find the most similar chunks when you are retrieving. That's why we need a vector database which is optimized to be used to store vectors and search through vectors. This is the first one. We can see here it routed the answer to the web search. So now it will retrieve the answer from the web search tool. Second question, what is recommended through deep learning with AI? To be honest, there are too much.
Yeah, it is.
Yeah.
That's why I asked you.
Yeah, so like the prompting courses is good. Language chain courses is also good. There is
Prompting.
two or three courses on CrewAI is good also, and there is courses on fine tuning and pre-training LLMs is good also. There is some courses on
Yeah.
RAG, they are good also. So yeah,
There is much, yeah. I'm
yeah,
just
So maybe you can
browsing the
just
deep learning AI
so
website you sent.
start by the prompting courses, and
Prompting.
there's two, and the language chain I think there is three courses. These are important, and after that you
Okay.
can take the CrewAI courses. There is two, I believe. They are good also on building agents, and after that you can if you need to learn something, you can search on the YouTube. You can take these courses. They are free also, so it's okay.
Perfect. Thank you very much.
Yeah. I hope this session was beneficial. We will
Oh,
conclude here
very
because
much.
it will take too much time. I will try to send the record after this session, and the code I will upload it on the GitHub repo I just sent here in the chat. Yeah, and thank you very much for joining, and see you again in the next session, John. Thank you very much,
Hopefully.
and see you.
Thank you.
Thank you very much.
Thank you very much.